Welcome everybody. We've been given this question. If x squared positive 2x positive 5 is a factor of x raised to the power of 4 positive b x squared positive q, then we are expected to find the value of 22 times of p positive q divided by sigma n is equal to 1 to 99 of 4n divided by 4n raised to the power of 4 positive 1. So this has got multiple branches that we need to solve. So foremost, what I wish to do is we will find out the value of p and q. Now, since x squared positive to x positive 5 is a factor of x power 4 positive p squared positive q, then this would mean x raised to the power of 4 positive p squared positive q is equal to x squared positive to x positive 5 times x squared positive. Now we need to have a x component here. We have a b term there, positive. The constant is going to be c. So this would be the form that we are looking at, right? So having given that information, we will have to make the following observation. So what are the observation? Now clearly we see that the x cubed term is missing. So that would mean the coefficient of x cubed is equal to 0. So this means coefficient of x cubed is equal to 0. So over here the coefficient of x cubed is found in this fashion. So b times x cubed, you have a x cubed term there, and then 2x times x squared, so that's 2x cubed is occurring there. So this is equal to x cubed of b positive 2. Now since x cubed term is missing, this means b positive 2 is equal to 0, so b is equal to negative 2. So outrightly we have got that value for b. So next, if you have to observe that we are also missing the x term. Is there any possibility of getting the x term? So 2x times c. So the coefficient of x is also missing. So this means the value that produces x, the coefficient of x, is going to be equated to 0. So c times 2x, okay, positive 5 times bx, there's another term there, and then is there any other term? So this multiplied with this gives me x term, and this multiplied with this. So if I were to take the x term out, this is going to be 2 times c positive 5 times b. So this is equated to 0. So 2 times c positive 5b is equal to 0. b is equal to negative 2. So 5 times of negative 2 is equal to 0. So this means 2 times c is equal to positive 10. So c is equal to 5. Fair enough, right? Is there anything else we can get? Okay, we have got, okay, we have obtained b and c. So this means x to the power of 4 positive px squared positive q is equal to x squared positive 2x positive 5 times x squared negative 2x positive 5. So this is easily obtained. Now we have to get the value of p. So coefficient of x squared, right, is p here. Okay, so this is p. Now we need to get the coefficient of x squared. So how do we get that? So 5 times x squared, that is one term, and then negative 4 times x squared, that is another term. Is there any other terms that we have? Okay, over here 5 times x squared. Is it not? I get a 5 times x squared here. I also get a 5 times x squared here. Okay. So this is nothing but x squared of 5 negative 4 positive 5. which is nothing but 6x squared. So over here coefficient of x squared is p, over here the coefficient of x squared is 6, so p is equal to 6. Okay, so that is got. So now the next is we need to extract the value of q, constant term. Okay, q is what? Q is nothing but the constant term. So 5 into 5 is 25. I do not get any other value or any other presence of constant in this system, right? Only 5 into 5 produces me this value for q. So I've got the value for p, I've got the value of q. So therefore 22 times of p positive q is equal to 22 times of 6 positive 25, which is nothing but 22 times of 31. So let me consider sigma. This is what we got, 4n over 4n to the power of 4 positive 1. N is ranging from 1 to 99. So we got 4n power 4 positive 1. I'm going to rewrite this as 2n squared raised to the power of 2. You expand this, you get 4n to the power of 4. Okay, positive 1. Okay, fair enough. Now what I wish to do is I would like to actually add 2 times of 2n squared times 1. So the idea here is to write this quantity 2n squared positive 1 raised to the power of 2. So if I were to expand this, I'm going to get 2n squared raised to the power of 2 positive 2 times of 2n squared times 1 positive 1 squared. So I have the complete perfect square here. But since I've introduced to this 2 times of 2n squared, I need to get rid of that. So it's going to be negative 2 times of 2n squared times 1. Okay, so this is rewritten as 2n squared positive 1 whole squared negative 2 times of 2n squared. Now this is of the form a squared negative. Can I actually write this as b squared? I can, right? So 2 times of 2n squared is equal to 2 squared of n squared, which is nothing but 2n raised to the power of 2. So this is going to be 2n raised to the power of 2, and which is going to be my b squared. Okay, so let me place a b there, and this is 2n squared positive 1 raised to the power of 2 negative 2n squared, right? In fact, I will just place 2n there and place the square there. So this is how it looks. Now a squared negative b squared is a negative b times a positive b. So this is going to be what I would do is I will write the first summation term first, the addition term first. So this is going to be 2n squared positive 1, okay, positive 2n, this is one term, and this is multiplied with the 2n squared positive 1 negative 2n. So this is the next term. Okay, so this is our 4n to the power of 4 positive 1. So therefore sigma 4n over 4n to the power of positive 1 is going to be 4n over 2n squared positive 1 positive 2n multiplied with 2n squared positive 1 negative 2n. Okay, so this is how the summation looks like. Now what I wish to do is I want to split this 4n. Now can I write this 4n as 2n squared positive 1 positive 2n negative of 2n squared positive 1 negative 2n. Do you think we can write it like this? Let us check. So this is 2n squared minus 2n squared, and then 1 negative 1, and then 2n negative of negative 2n, that's going to give me 4n. So this is a valid representation. So if we were to take this as 2, therefore 2 is rewritten as sigma 2n squared positive 1 positive 2n negative 2n squared positive 1 negative 2n divided by the product 2n squared positive 1 positive 2n multiplied with 2n squared positive 1 negative 2n. Okay, now a negative b divided by c can be rewritten as a over c negative b over c. Okay, so this is going to be 2n squared positive 1 positive 2n divided by 2n squared positive 1 positive 2n multiplied with 2n squared positive 1 negative 2n. Okay, and then followed by negative sign 2n squared positive 1 negative 2n divided by 2n squared positive 1 positive 2n multiplied with 2n squared positive 1 negative of 2n. So this entire thing has got a sigma bound. It's covered by sigma. So 2n squared positive 1 positive 2n, this goes off. 2n squared positive 1 negative 2n, so this goes off. So you have sigma 1 over 2n squared positive 1 negative 2n, this is what is present, followed by negative 1 over 2n squared positive 1 positive 2n. Okay, 1 to 99. So let's go to the next side. Now if we take f of n to be equal to 1 over 2n squared positive 1 negative 2n and find f of n positive 1, this is going to be 2 of n positive 1 whole squared positive 1 negative 2 of n positive 1, right? So this is equal to 1 over, I expand this is going to be n squared positive 2n positive 1 positive 1 negative 2n, okay, negative 2n and then negative 2. So this is equal to 1 over, expand this, distribute 2, you get 2n squared positive 4n positive 2 negative 2n negative 2. Positive 2 negative 2 goes up. So you have 2n squared, you add this, you get 2n squared, 4n negative 2n is positive 2n, and then you have okay, there is this positive 1. Okay, so this positive 1 should be also brought in, right? 2n squared 2n 2. Okay, so that positive 1 should be placed. This has been missed out, so I'm bringing it down here. Now what is this? This is exactly what we have here, right? 2n squared 2n squared 2n squared 2n positive 1 positive, right? So therefore sigma 1 to 99 of 1 over 2n squared positive 1 negative 2n negative 1 over 2n squared positive 1 positive 2n is rewritten as sigma 1 to 99 of f of n negative f of n positive 1. So this is what we have got. Okay, so I'm running the value of n from 1 to 99. So if we were to do that, I get a first value f of 1 negative f of 2 plus f of 2 negative f of 3 plus f of 4 negative f of 5 plus f of 6 negative f of 7 plus etc. Then negative f of 99, right? So this is okay, plus and minus, so this is plus 99 negative f of 100, right? 99 means if you substitute n is equal to 99, this will be f of 99, followed by negative 99 plus 1 gives me 100. So the first term will not be affected. Second term, third term goes off. The third term, and this is going to be, there is going to be an intermediate term, because I should have placed this 2 and 3. So this is etc. Okay. So probably I will introduce this because n is equal to 2, you get f of 2 minus f of 3. N is equal to 3, you get f of 3 minus f of 4. So f of 3 minus f of 4 plus your continuation, f of 4 negative f of 5. So negative positive goes away, positive negative goes away. So all these terms will get hit, annihilated. All of them will be gone, excepting the first term and f of 100, the last term. But f of n is equal to what? 1 over 2n squared positive 1 negative 2n. So therefore n is equal to 1. F of 1 is going to be 1 over 2 positive 1 negative 2. Negative 2 positive 2 goes out, giving you 1. And f of 100, f of 100 is going to be 1 over 2 times of 100 squared positive 1 negative 2 times of 100. So this is nothing but 1 followed by 4 zeros multiplied with 2. So this is going to be 2 followed by 4 zeros, right? And then plus a 1, so this will become 1. And then you subtract 200. So if you subtract 200, you get a 9 there. From, oh, you just need to, the 1 will be brought down. There's no 9 there. 1 will be brought down, right? A 0, and then you have 8 there. And since 1 is borrowed, you have a 10, that from that value 10 again 1 is borrowed, so you get 8. So this is going to be 9. So you have 19801. This is the value you get. Okay. So therefore f of 1 minus f of 100, you need to still calculate this. It's going to be 1 negative 1 over 19801. I take the LCM as 19801. You get 19801 minus 1, which is nothing but 19800 divided by 19801. So we did all these things to obtain the summation of 4n divided by 4n to the power of 4 positive 1, n running from 1 to 99. Now the time comes to substitute the values. So we've got the p of, so 22 times of p positive q divided by sigma 4n divided by 4n to the power of 4 positive 1 to 99. Now this is nothing but 22 over 31 divided by this quantity. This quantity is 19800 divided by 19801. So you flip this quantity, you get 22 times 31 multiplied with 19801 divided by 19800. This is going to be divisible by 22. 22 divides this 9 times, right? You have how many zeros? You have 2 zeros there. Okay. Now that is the maximum we can go forward. Okay. So this cannot be divided any further. So what do we have? We got 19801 multiplied with 31 divided by 900. This is the maximum we got. Now if you want, probably you can multiply 19801 by 31. So what do you get? 10891 3024 2 29 2 5 divided by 1 3 8 13 10 11 and 6. So this is what you get. This is divided by 900. Okay, so the outcome is 613831 divided by 900. Can we reduce it any further? If you can reduce it, you reduce it and put the solution in the comment box. So that's the end of this particular question. This is a lovely question. Thank you everybody. Please like, share and subscribe.